Good morning, children. Welcome to the online classes of our Regina School. Okay, children, uh, please close your eyes for 15 seconds and think of your favorite god so that your concentration and focus level will definitely increase. Okay, my dear children, welcome to once again. I am welcoming you to the 8th standard IIT Chemistry online session. My dear children, as of your 8th standard, I think there is no need to tell what is IIT, how it is important to you. So, you are all aware of IIT. Even then, I want to tell you one thing that studying IIT in the sense you are learning the concepts much clearly and you are avoiding the by-hearting nature of by-hearting nature, and you are learning the concepts in a systematic way. Okay, this is what you are doing in IITs. Okay, now I will show you how the textbook of chemistry textbook, IIT chemistry book of our school, and what are the concepts you are learning in that, and what is the first lesson. We will see all these things. Okay, take your book and pen and just okay, children, see here I am showing you the textbook of IIT chemistry. This is for class 8th. Okay, and our first lesson is language of chemistry. Okay, nothing but what is language of chemistry. So this is the first unit we are studying in our 8th class IIT chemistry level in today's session. Okay, children, in this we will see some introduction, synopsis 1. I think you are aware of how the textbook of our school IIT book that is. So synopsis 1, some introduction it is given, and what is symbol, significance, everything we will see, concept of valency. Okay, today we will see synopsis 1. Okay, now good morning, children. See here, I already showed you how the textbook is and what is the first chapter, that is language of chemistry. This is the first chapter we are studying in IIT chemistry. So synopsis 1. In synopsis 1, okay, the topic I am telling you, symbol. Okay, what is this symbol we will see. Okay, see here I wrote the definition. A symbol is defined as the shorthand sign for the full name of an element. See here, a symbol is defined as the shorthand sign for the full name of an element. Okay, shorthand sign for the full name of an element. Who introduced this? Berzelius. So Berzelius is the scientist name. Okay, Berzelius is the scientist name. He introduced the symbols, that is shorthand sign. Okay, he suggested this method. See here examples. Hydrogen, how it is shown, H. So using English alphabet letters, okay, using English alphabet letters, he suggested this method, that is shorthand sign for the full name of an element. See here hydrogen, we have how it is indicated as H, first letter we have taken. What about the next element, that is carbon, how it is shown in the, see here we have taken first letter, that is C. What about oxygen? Here also we have took first letter, that is O. My dear children, like this, how many elements do we have really? We have total 118 elements. Okay, we have 118 elements in the periodic table. So, are the 118 elements all represented taking this first letter only? No. Okay, some are taken first letter and second letter. Okay, first two letters, using first letter like this we have represented. Who suggested this method? Berzelius. So the scientist name is Berzelius. He suggested this method of representing the elements, that is taking the first letter or first two letters. Okay, see, we have total 118 elements. Now see here, my dear children, symbol, actually this symbol, that is hydrogen, carbon, oxygen, what are these symbols? Now these symbols represent one atom, that means H. I have shown you example, hydrogen, H. Here H means only one H it is there, so it is one atom. We all know every element is made up of atoms. Okay, matter is made up of millions and millions of atoms. So in that we are taking elements, that is hydrogen, oxygen, all these are atoms. Okay, I told you matter is made up of millions and millions of atoms. Okay, now this matter, what are those atoms? The atoms might be some in the form of that elements. Those elements are hydrogen like this. Here the symbol, okay, symbol 1H, that is a single H is shown here, that means it represents one atom. If I take two hydrogens, then it is representing two atoms. Similarly, if I take three H, that is H3, three hydrogens I am taking, that means it is representing three atoms. Once again, see, my dear children, symbol. What is symbol? A symbol is defined as the shorthand sign for the full name of an element. So in a complete name, that is hydrogen, so we are taking only first letter, that is H. Here we are taking, in the carbon we are taking only first letter, that is C. Like this we are representing. Every time we are not representing with only first letter, but in some cases we are taking first two letters also. Actually, who suggested this method? Berzelius. So the scientist name is Berzelius. He invented or suggested this method. So how many elements we have? We have total 118 elements. Okay, we have total 118 elements. Now this symbol represents, each symbol represents one atom. If we take two symbols, that is H2, that means we are representing two atoms. If we are taking three symbols, that is H3, that is H is taken three times. Here in the suffix I wrote 3, that means H is taken three times, that means we are having three atoms. Okay, now see, my dear children, a symbol, that is symbol represents the mass of element equal to its atomic mass. Okay, once again, a symbol represents the mass of, here number of atoms, symbol represents the number of atoms, that is if only one it is there, it represents one atom. If two is there in the suffix, it represents two atoms. If three is there in the suffix, it represents three atoms. Similarly, the symbol represents the mass of element. Okay, what is the mass of element? That is nothing but atomic mass. Already symbol represents the atoms. Similarly, this atoms has some mass. Okay, matter is having mass. Okay, so this atom is also having mass, that means symbol is representing the atom and at the same time it is representing the mass of these atoms. Okay, a symbol represents the mass of the atoms, that is nothing but atomic mass we call. Okay, before going to see what is atomic mass, we just know we just learn what is atomic number. Okay, now what is atomic number? Atomic number is nothing but number of protons. What is atomic number? It represents the number of protons. Okay, see here, generally in an atom, okay, this is nucleus. What I draw is nucleus. In that, protons, neutrons, and in the orbits we will have electrons. This is electron, proton, neutron, and this is nucleus. Okay, so this number of protons, how many protons are there? That is equal to the atomic number. So if the atomic number is 7, then we have 7 protons. Okay, in fluorine example, in fluorine, okay, in fluorine we have, okay, in fluorine we have 9 protons. That means atomic number of fluorine is 9. Okay, in chlorine, that is, see here I am writing chlorine, that is represented as Cl. Okay, it has 17 protons. 17 protons. That means chlorine has 17 protons. Means what means? It means atomic number of chlorine is 17. Okay, now like this, atomic number means number of protons. Generally in the atom we have nucleus. Okay, again in the nucleus neutrons and protons are present. Sometimes this protons is equal to neutrons in most cases, but in some cases neutrons might be greater than this proton in number, not in size, in number I am telling. Okay, see here atomic mass. Now come here, atomic mass. Children, this is your empty bag or empty basket. So while coming to the school, you have filled your bag with a physics textbook, maths textbook, okay, chemistry, biology, okay, homeworks, English. Like this you have filled your bag with all the books. Now tell me, it is an empty bag. Now you filled this bag with all the books. Okay, what are these? You filled your bag with all the books. Now tell me the mass of this bag. That means your English book, mass of English book, mass of physics book, mass of maths book, mass of chemistry book, and mass of some biology book, and your homework notes as mass. So the addition of all these masses is equal to the mass of your bag. Similarly, if you have a basket, this is an empty basket initially. Now you filled the basket with some vegetables and some fruits. Now some of these vegetables, some of the mass of these vegetables and mass of these fruits is equal to the total mass of this basket. Okay, similarly here in atom, so this is atom. In the atom you have nucleus, this is proton P, this is neutron. Okay, now this one is electron E. In an atom you will have nucleus, and around the nucleus you will have orbits. Okay, in that orbits electrons will be rotating. Now in the nucleus what you have? Proton and neutron. So then what is the what we are studying actually? Atomic mass. Atomic mass means the mass of the electron. So mass of this electron is negligible. Okay, but actually I told you in the basket and bag case, see here, every individual mass is you are counting. Similarly, when you are coming to the atom, you have to take the mass of proton, neutron, electron. All these masses, addition of all these masses will get you atomic mass. But in practical, the mass of electron is negligible. So you are neglecting the mass of electron. Okay, now see here, my dear children. Now what is the atomic mass? That means proton mass you are considering, neutron mass also considering. That means total mass, total atomic mass is mass of proton plus mass of neutron. Okay, mass of proton plus mass of neutron, that is total number of protons is plus total number of neutrons. Example I am showing you, see here, my dear children. Take the example of fluorine. Okay, take the example of fluorine. In fluorine, so this is a fluorine atom. You have 9 protons and 10 neutrons. Due to lack of space, I am writing outside, but it is actually here only 10 neutrons. So like this, you have 9 protons, 10 neutrons. Now what? Okay, what is the mass of fluorine? That is 9 plus 10, 19 units. Okay, 9 plus 10, sum of these protons and neutrons will give you atomic mass of fluorine. What is this? Atomic mass. Okay, atomic mass. Now come here. See here, children, I already told you previously, number of protons is equal to number of neutrons in most cases, but in some cases we will have more neutrons. Sir, if neutrons is more, is there any effect? No. What is the charge of neutrons? Before going to talk about the effect of more neutrons, whether there is effect or not, we will see later. But tell me one thing, my dear children. Already you are 8th standard, that means you know what is chemistry. Already chemistry is introduced to you at 6th standard level only now. So that is why I am asking you a question, simple question. What is the charge of neutrons? What is the charge of protons? What is the charge of electrons? Okay, the charge of protons is positive. Okay, charge of protons is positive. See here, protons have positive charge, electrons have negative charge. What about neutrons? Neutral, that is no charge. Okay, my dear children, for neutrons there is no charge. Neutrons, there is no charge. So let us discuss again, come back. I told you more neutrons are there in fluorine. Is there any effect? No. However, neutrons are neutral in charge, so there is no effect for the atom. There can be more neutrons, there can be equal to the number of protons, but you will not find less than protons, definitely. Okay, charge will not affect, any charge is not affecting. Why? Our neutrons have no charge, that is neutral charge. Okay, now take the example of chlorine here. Come here, 17 protons, 18 neutrons. Okay, in chlorine atom has 17 protons. What is the atomic number of chlorine now? 17. That is number of protons is equal to atomic number now. So what is the atomic number of chlorine? 17. So now let us calculate total mass here, my dear children. Total mass is 17 protons plus 18 neutrons. That gives you 35. Okay, 17 plus 18 is 35. This is the total atomic mass. Like this. Okay, now this 35 is represented by chlorine, Cl. Now the symbol of chlorine is Cl. Now Cl representing total mass, that is 35, and as well as atom. How many Cl's are there here? 1 Cl. That means 1 atom. What is the atomic? Now this Cl is also representing 35 units of atomic mass. What about fluorine? Come here again. Fluorine means 1 atom. F, that is fluorine, 1 atom, and it is representing 19 units of atomic mass. Okay, like this symbol is representing the atom and is also 35 units. Okay, now take here, come here, my dear children. Cl, chlorine, representing 1 atom. Okay, atomic mass of this Cl, chlorine, is 35 units. Now suppose if I take Cl2, 2Cl or Cl2. Okay, 2Cl, that is 2. How many atoms here now? 2 atoms. Okay, what is the 2 atoms now? It is representing what will be the atomic mass of this Cl2? 35 plus 35. Okay, 35 plus 35, 70 is the atomic mass it is representing. Okay, now it represents 1 atom. It represents, here it is representing 1 atom, here it is representing 2 atoms. I hope you understood what is symbol. Okay, now my dear children, now let us come to the next topic, atomicity of elements. See here, children, now till now we have seen what is symbol, who invented this symbol, and significance of symbol. Like this we are seeing, and atomic mass we have seen, atomic number we have seen. Okay, like this we have seen. Now see molecule, that means what is molecule? Combining of 2 or more atoms is called molecule. Once again, combining of 2 or more atoms is called molecule. See here, example H2O. Here normally H, it is a symbol. Okay, that means it is representing 1 atom. Okay, if I take H2, it is representing 2 atoms, and O, that is oxygen, it is representing 1 atom. Like this, 2 different atoms are combining, that means it represents 1 molecule of water. Okay, what is H? Here see HCl. H is representing 1 atom. Cl, that is chlorine, is representing 1 atom. Combining of these 2 different atoms represents HCl, that is 1 molecule of HCl, hydrochloric acid. Like this it is representing molecule. What is molecule? Combining of 2 or more atoms is called molecule. Okay, now see here, my dear children, come back. We will see atomicity of elements. So the number of atoms present in one molecule, you know what is molecule? The number of atoms present in one molecule of an element is atomicity. Okay, number of atoms present in one molecule, so is called atomicity. See, atomicity is divided into three types: mono, that is one; diatomic, that is two; di means two; polyatomic, third type is polyatomic. Polyatomic means, okay, polyatomic means it is greater than 2. Okay, see here example Cu. Mono means one atom. Okay, one atom, one atom, one atom, one atom. See, all are one only now. There is nothing in suffix. You observe here, there is nothing, no number in the suffix. What is diatomic? 2. Di means 2. Observe here hydrogen. How many hydrogens? 2. In the suffix you are observing 2 number 2. That means 2 atoms. I already told you symbol, it represents one atom. Here how many symbols are there? How many hydrogens? 2. That means 2 atoms it is representing. That means atomicity is 2. Here also 2. Oxygen. What about nitrogen? 2. Come here, polyatom. Here what is the atomicity? 3. What is the atomicity here? 4. Like this, the atomicity can be mono, di and poly. This is what atomicity, my dear children. With this, what is molecule? Okay, what is the atomicity? What is symbol? What is the significance of this symbol? Okay, what is atomic number? What is atomic mass? I think you understood all these concepts. Okay now, my dear children, for first class this is enough. Okay, in the next session we will see what is valency, how to find the valency of an element we will see. Okay now, thank you.